Hi, I'm Andy. Welcome back to C Sharp Puzzles, Puzzle 3. Let's talk about numbers, maths, and money. We have to learn how a computer program saves numbers, so they could be integers, they could be floats. We also have to talk about money. Money has to be a bit more accurate than how we would handle just regular numbers. And then maths, you're going to always have to do some basic maths as a programmer. I don't want to scare you away. It's not super advanced stuff. I'm not a great mathematician. I've been to university, but I'm not a great mathematician by any stretch of the imagination. You're mostly playing around with data, and a lot of data can be numbers. So you have to know how to basically chop up numbers, move around numbers to sort of manage the data in your much bigger application. So let's just discuss maths, let's discuss numbers, and then show me the money, okay? Let's get puzzling. Beginner's puzzle number 3. The link to this repository is in the description. Again, we want to copy the HTTPS URL. We use GitHub Desktop. Again, we can see all the additions and subtractions we've made in our previous repo. So let's go to clone repository, go to URL, paste it in there, make sure it's in the right place, click clone, and that's you downloaded the code for these puzzles, and we can see it here. I'll open this up, and I'll just remind you that had you downloaded Git separately, you can use the command line here to clone stuff, and you would just paste the URL in there. Okay, but let's try and use the Git client. Okay, let's take a quick look at this. This is all going to be about numbers and maths and money. So I hope you've done a bit of this before. If not, it's not too difficult. Obviously, it's not just a computer program, it's also a calculator. And an awful lot of the work you would do as a professional developer will involve numbers. Not so much doing maths like this, but manipulating data, managing large amounts of data. So there's going to be maths involved. So we've got example A here, which is just really introducing integers and getting numbers from the user. Okay, because when we use console readline, that takes the user input as text. But text is not a number in C Sharp. So we have to kind of convert it to a number. This is called parsing. And there's different kinds of numbers as you'll find out in these examples. There's integers, which is kind of like the catch-all. If you're a beginner, most things will be an integer, unless you need like floating points or numbers after the decimal point, or you maybe want to try to save some memory. So in this example, we're really just taking the user's input and converting it to a number and then displaying it. So puzzle A is asking you to do something similar, but to do maths in that number, to use division. And in the computer programming, there's a big difference between division and remainder. So you kind of have to know that the difference between like 10 divided by 2 and what the percentage symbol represents, the remainder. So once we cover that, example B is next. We're talking about Elon Musk because he's always on the social media, right? I wish he would give me some free money. And this time we're talking about floating points. So the decimal points after the 0. If you save a number as an integer, it won't have any decimal points. You can't save 1.2 as an integer. You have to save it as a floating number. Okay. So there's also a double in C Sharp. not all languages have all of these. Some languages have some. C# has them all. And I'm kind of showing you a bad example here. You probably shouldn't be using double as money, but it's kind of like the first thing a beginner would think. Hey, if I've got $5.50, I can't save that as an integer. It must be a double or a float, right? So we can kind of use that as an example here. But for puzzle B, I kind of want you to read up a bit on money. You don't really want to save money as a double or a float. You want to save it as a decimal. And there's reasons for that. You should maybe read into why we use decimals as money. In example C, we're bringing up random number generation. So this is very common in all sort of beginner projects. Maybe it's rolling the dice, maybe it's like making a lottery program or something. It's also useful just generally in programming for data manipulation. There's maybe going to be situations where you get a lot of data and you want maybe the data to be unique in that cell, so you want to just choose a random number or make it a random string or something. So learn about random. I've called it Randy. I really probably shouldn't have done that. Numbers aren't Randy, guys. They're just numbers. And for puzzle C, you have to pretend you're working for the tax department, which is awful. Is awful. So we can sort of simulate how much of our pay slip they're going to take away from us in this example. Okay, so again at the very bottom, what I would do is I would comment out the examples, and then whatever puzzle you're doing, just uncomment the puzzle. Yeah? And that will run the puzzle, and then you can just take away these comments and run the puzzle. Let's run the examples. So I'll uncomment the examples and we'll run them, and I'll kind of show you what the program's all about. Okay, click the play button. Let's see if it runs. How many drugs do you want to buy? I want to buy 1,000 drugs, please. This is a police sting operation. You're under arrest for buying 1,000 drugs. Naughty, naughty. Well, it really depends what kind of drug it is, isn't it? Elon Musk is drunk again. Was he ever sober? And we are giving away free money on social media. I want a lot of free money. I want $10 million. I think that would probably buy me a house in Australia, a small one. Oh yeah, that's good, because it sent me 20 million in, didn't he? Example C, rolling the dice, you rolled a 4. Oh well, I hope that makes me win the game. So there's the program running, guys. Like I said, comment out the examples, uncomment the puzzles, remove the comments, and start coding. Again, use Google, use AI, use whatever. Textbooks are good as well. It's good to get a feel of numbers because they're just going to be there. You're going to have to manipulate data in your job. It's probably not going to be as much as like 5 times 7 divided by 2 sort of stuff, but it is going to be part of your job, playing about with data that you've probably got from a database. Okay, I hope you had an attempt at that. Let's take a look at the solution. As always, there is a solution branch available in the Git repo. You can select this. You can clone all this and run the solution, or you can just look in this folder and look at program, and there's the answers. Let's look at the code. So first off, I'll go down to the bottom and I'll comment out all the examples because we don't need to run them. I've already demonstrated them for you. And I'll uncomment puzzle A because that's the one I want to run first. Get rid of the multi-line comments there. Puzzle A is active now. Puzzle A maths stuff. Write a program that asks the user to input two numbers. Add the numbers together and display the result. Subtract the second number from the first number and show the result. Multiply the numbers, divide the first number by the second number, show the answer, whole number and remainder. Divide the first number by the second number and get a fraction. Okay, so that's basically all the maths operators, right? It looks like it's asking for a lot, but most of these are just going to be one line of code. There's not going to be much to them. So we need to get two user inputs first. Let's copy this and then we can modify it. So we can ask them to enter a whole number first, please, because we're nice people. And what I'll do is I'll write whole in all capital letters, because we're going to convert this into an integer, and if they type in something that's not an integer, the program will probably crash. So let's just explicitly say whole here. We've not got any other error checking. So what I'm going to call this is I'm going to call this num input 1, okay? Because we have to convert this from a string into an integer. Console readline saves everything as text, as a string. So up here we've kind of got this parsing in the example, so we can use that. And we can just create an integer called num1, and then we can parse the number input. So you see how the variable names are becoming quite specific. This isn't num1, this is num input 1, this is number 1. Because later on in the program, you might, 100 lines of code later, want to use these variables again. So is num1 a number, or is it text as an input? If it's an input, call it an input. There's many different sort of naming conventions and strategies. This is the one I like to use. Developers aren't people, developers are something different. Developers like to argue over the semantics of this a lot. Everyone has an opinion, so we'll ask them to enter a second number. And it'll look something similar to this. So we'll call it num input 2. Now, I've kind of demonstrated to you how you can use parsing, and that's how we did it in the example. But there are other ways of doing this. I believe in the example we used this, convert to int32, which is just another technique. What you'll find is C# sort of an older language. It's been around for a while. So maybe 10, 15, 20 years ago, whatever, only one of these was available, and then another one was added to maybe it's faster, maybe it's better used in certain circumstances. C# usually has multiple ways of doing the same thing, and each of them's better in a specific situation. It's up to you to decide what you like best, and this is why developers have conventions in their coding. Maybe one team likes this because it's shorter, maybe other teams like this. Okay, so we've got both inputs now. We've saved it as numbers. Might be null. Yeah, okay, that should be num input 2, guys. Right, so the first thing they're asking us is addition. So let's just do the sum. It's going to be an integer because we're adding two integers, so we'll just call this add result. You could call it add, it's the result of the addition is what I'm thinking. So really easy, just num1 plus num2, right? That's all it is. That's going to give us our expected output, and we'll just tell the user what the result is. So using our string interpolation again, we'll just display the sum. Oh, it's kind of went a wee bit weird on me there. Okay, so you see how we're continually reusing what we've learned so far. So that's the add result. I think that's fairly straightforward. Subtraction next. And again, it's going to be very similar. We're just going to change the sort of, what would you call it, the operator sign, the math sign. I think almost everyone should have got both of these, right? Fairly simple. It's the next one that's difficult. Oh no, sorry, multiply is next, isn't it? Again, easy. Just change the symbols. And it's star for multiply, guys. It is not X. Okay, it's star. Divide is, division's a bit trickier because it's, we've all kind of seen these symbols before, but division's a bit weird in computer programming if you've never done it before, so we'll just take it as an int. Divide result. A lot of people might think that's as far as you need to go. It's not, I'll show you, so we'll do the remainder. Just copy this again. Divide result. And actually, if I comment this out just now, I don't think we need a second one. What I'll do is, I forgot the capital R, has to match exactly. And we can do the remainder there. That should be good enough. Okay. Let's run that so far, see what we've got. Please enter a whole number, 5. Please enter a second whole number, 2. Let's keep the numbers nice and low so my brain can handle it. 5 plus 2 equals 7, that is correct. 5 minus 2 equals 3, yes. 5 times 2 equals 10. 5 divided by 2, that is correct. So there's 2 2's to make 4, and there's one remainder, 5. Now you'll notice that when you did 5 divided by 2, it did not give you a decimal point. If you were in a calculator and you did 5 divided by 2, you would get 2 point blah blah blah, right? 2.5. But it didn't give you that, it gave you 2 as the divide result, and you had to do a second sum to calculate the remainder. Alright, but how do we get 2.5 there? Because it's not going to use the 2.5 because it's an integer, right? If I stop this and I run it again, and I do, let's say I type in 5.5, well, if I click on it, 5.5, program crashes because an integer cannot handle a floating point number, input string 5.5. It can't convert that into an integer. So okay, so how do we maybe get like 2.5 there? Well, you have to use double. So what I'll do is, or a floating point, I'll just use double. Say if it's a type double. Now, you might think that's good enough, it's not. So num1 divided by num2, say if it's a double, but these are both integers. So what you want to do is you could go through parsing or you convert or whatever. An awful lot of programmers will just use casting, which means in C#, in brackets before the sum, you just put the name of the variable you want. So I want it to be a double. I want this sum of integers to be a double. And then I can just use this in this example here. So I'll just call it divide double. And that should give us the 2.5. Let's run it again. Interval number 5. The second whole number 2. And you see we get 2.5. So that's, most beginners would think that was unusual, the way that operates there. And you'd be surprised how often that catches you out. You know? Okay. That's a good little demonstration, I think. We'll uncomment comment puzzle A. We'll uncomment puzzle B. And we'll go take a look. Example B, Elon Musk. So again, we're using casting there for the float, which you just demonstrated. So you could also have used double.parse. Yeah, okay. What are they asking us to do? Let's uncomment this. Decimal is usually used for money, not float or double. It is more accurate. It is more accurate. Write a program that asks for donations to a charity. Get the user's donation amount as a decimal. Elon Musk will match the amount the user enters. Good on him. Output the user's donation amount and the total donation after Elon matches it. Okay. So the reason you want to use decimal for money is when it comes down to decimal points and how accurate they are, and how the rounding up and rounding down kind of goes. At very long numbers, which, I mean, like, although we think like 5.51, $5.51 is as good as it gets in banking, they might actually be using fractions of a cent. So they have to make it super accurate. Okay, let's take a look at this. Let's just ask them how much they'd like to donate. So we can just copy one of our prompts, something like that. So I suppose we should ask ourselves, what kind of charity would Elon Musk donate money to? That's what I think he would donate money to. So our input would be, let's just, because it's money, let's just call it money input. And then let's just start this again because we want it to be decimal. Let's just call the decimal money. You can use parse, I suppose. If I could spell correctly, that's not correct. Camel case. Now, you've kind of got to think logically what kind of problems we're going to get here. I've not shown you yet what happens if the user enters a bad number or something intended to break your program, but we can kind of guess here that a decimal can be anything, you know, any number of numbers after the decimal point. Okay, it could be, the user could enter 5.12345. But we really just want 2 decimal places after the point. So we should probably stop the user from doing that, or in our case, we can just round it up. I think probably rounding the money up is probably easier. And we see here in the example, they've used math.round because if the user enters 7 decimal places, we just round it to 2, and then that's good enough for our program. So we can just copy this really. We don't want it to be a double, we want it to be a decimal. Okay, now if we read the brief, get the user's donation amount as decimal, we've done that. Elon Musk will match the amount the user enters. Okay, so we'll kind of have to double this to get the final total, don't we? Let's keep it as decimal. And again, I like copying and pasting variable names so I don't make any mistakes. Why is that behaving like that? I've missed something, haven't I? There we go. And then we can just output the answer. Oh, don't forget the dollar symbol. There we go. And let's not forget the name of our favourite charity. Well, that would be your favourite charity if you were a billionaire, wouldn't it? And then we can just display the matched total. I'd say that's probably good enough. As long as you get something like that, as long as you were doing the rounding and the parsing and you use decimal. Really, I really wanted to hammer home that as soon as you think money, think decimal. Okay? Something like that, as long as you get the output, fantastic. Let's take a look at the next one. Let's comment out puzzle B. Take a look at puzzle C. Death and taxes. Write a tax department program that asks the user to enter the yearly salary, randomly generate a percentage between 30% and 100% to tax them. Wow, that's horrible. That's horrible, isn't it? Calculate what they will pay in tax. The tax department works using whole numbers, and they do if you've ever submitted a tax return in Australia. So if they enter a floating point number, round it up, thanks, to a whole number, tell them the bad news they often use, let them know the tax percentage they are paying and how much they will pay in tax. There's an old joke from a UK television show, I think it was called Yes, Prime Minister, where they explain to you the tax department doesn't calculate how much money it needs and then, you know, divide it up amongst all the citizens and decide what to charge them. No, it just pitches for how much it could possibly get in the first place and then decides what to spend it on. So this might be actually what they use in the tax department. Again, we need, well, let's just give it a title. You know, I'll just call it Tax Department. And then we'll just want our sort of inputs again. Just copy them. Oh. Yeah, copy the whole thing. You must enter your yearly salary or you will be arrested. Yep, you can commit many crimes in this world, but not paying your taxes is one they will definitely put you in prison for. So it's not money, it's salary. We kind of have to be specific. Just edit this so that it fits what we're trying to do. So again, copy and paste. You know, once we've used code once, we don't need to type it out. We don't need to make mistakes. We can just copy and paste it and edit it. Now again, we've rounded it because they go by whole numbers, remember, so not 2 decimal places. It would probably be 0 there. Yeah, to make it one whole number. And then we can just generate a random number, right? You will use this a lot in your coding life. Random. It's not a roll, it's just tax. We're trying to calculate the tax. So we want the tax to be between 30 and 100%. So as long as it comes up with a number between 30 and 100, we can just use that as a percentage, right? So the calculation, and we'll use decimal because it's money, tax to pay. We take their rounded salary because we're using whole numbers, and we'll multiply it by the tax that we've calculated, so the random number between 30 and 100, and then we'll just divide that number by 100 to get a percentage, right? That should work. And then we'll display the answer. And we'll just put the percentage sign in there because it's just going to be a number. So I think that should probably work. Yeah, I think that'd be okay. That'd be an acceptable answer. So you've kind of got to know your sort of maths there to come up with that. It's not difficult, but you see how you're breaking a problem down? You're given like a fairly complicated brief there. You've got to know how to parse things into decimal, got to know how to use decimal for money, got to know how to use random to get a percentage, do a bit of maths. Let's have a go at doing these puzzles, demonstrating them. Okay. Puzzle A. Please enter, well, we've kind of demonstrated this already. Please enter a whole number. We'll do 7 this time. Please enter a second whole number, 3. There's all the answers. 2, blah, 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 blah. How much money would you like to donate to Sex Addicts Anonymous? To be honest, I'm just going to give them $10. You need 10 to Sex Addicts. See, we maybe should have put a dollar symbol there. And Elon Musk has matched donation, total donated $20. He'll be getting something out of this, I'm sure. Puzzle C, Tax Department. Oh no, you must enter your yearly salary or you'll be arrested. I'm going to lie. I'm going to tell them I only make $10,000. You need to pay 70%. Jeez, $7,000. They're killing me. They're killing me. I'm really glad I lied. Okay. So that's us, guys. If I go back up here, I'll just add in that, get rid of that space, add in a dollar symbol. So if you came up with anything like that, good. This is just demonstrating that you know numbers, you know maths, you know money, you know a bit of division, you know percentages. Well done for getting through puzzle 3. Yeah, numbers can be difficult, maths can be difficult. I remember I used to be really good at maths at university, but I just kind of lost touch with it, I guess. I used to have to do really long sums in university. I used to be a telecommunications engineer. We used to have to like write 7 A4 sheet pages of sums to calculate like the frequencies of various radio equipment. That's the most maths I've ever done, and in my actual development job it's more about moving data through the application rather than doing these long sums. When we've had to do things like that, I've actually had data science people that did it for me, and I just kind of, it was almost like they were a black box, like a little program of their own. You just sent them data and they sent you the data after they'd done all their sums and maths on it. And it used to always freak me out how much those data science people liked maths. Anyway, as always, the same puzzle was covered on my Python channel. Check it out if you're interested. Thank you very much.